Hello, everybody. This is lesson 7 in Math 100. So starting in lesson 7, we are going to talk about money, okay? Now, again, you can't argue that this is not so important, right? I mean, a lot of times you say, well, all the math stuff is not that relevant in my life. And that may be true in other classes, but not so in the liberal arts math course, okay? So we talked about logic, and then we talked about, problem solving and so on. All right, now we get down to one of the most important things in life, money. Okay, so starting in lesson 7, lesson 7 will be talking about a one-time deposit and how that grows with simple and compound interest. And in lesson 8, we'll talk about saving money by a series of payments. And then in lesson 9, we'll be talking about probably the most important lesson about how to borrow money and how not to borrow money, because borrowing money is could cause a lot of problems. Okay, so we'll be talking about the money things for the next 3 lessons. All right, but we'll start with something simple and something compound. But lesson 7 is the foundation for the other 2 lessons. So let's learn lesson 7 well. Okay, so this is about simple and compound interest. All right, lesson 7. Just a little comment here before we go on to the content of the lesson. Sections 3.1 and 3.3 are both covered in this one lesson. Mostly from the first section, but the section 3.3 has this thing called continuous compounding. So we'll cover both of these together. And so at the end of this lesson, you should be able to do the homework exercises from 3.1 and 3.3 as well. They both deal with, and this is important for you to know because this is different in section 2, which is about the next 2 lessons. But these topics in 3.1 and 3.3 both deal with a one-time deposit. Okay, so you have a certain amount of money that you're depositing once into an account, and that is going to grow with either a simple interest or, more importantly, compound interest. Okay, not a series of payments like annuities or saving up for future, like monthly installment or monthly payments and so on. All right, so get your calculator out. I will be talking about calculators in a minute. Okay, one important thing is you should get a scientific calculator because starting in this lesson, you will be using a scientific calculator. And one thing that you should look for in your scientific calculator is either this key, which is called the caret key, C-A-R-E-T, not the red vegetable, orange vegetable, or this is identical. These are the same keys. And so every scientific calculator should have either this or this key. And so this is exponential key. And so 2 to the 5th, for instance, that's 2 times 2 times 2 times 2 times 2. And that is, of course, 32. But you enter to find this, you do 2, either caret 5, and that's going to give you 32, or 2 to the power of, and that's what x to the y means. Okay, and either one of these should give you the answer of 32. Okay, so make sure you find that, and I will be showing you a scientific calculator that comes with any sort of Windows, an operating system. But make sure you know how to use that. Okay. All right. So the topic of this lesson is basically compound interest. Okay. Now I said there are 2 types of interest. We'll be talking about this, simple and compound. But simple is so simple that we will not be talking much about that as nearly as much as a compound interest. All right, so the topic is a compound interest. How does this work? Okay, now again, there isn't a topic that is much more important than this one, okay? Because this will either bless your life if you save money or curse your life if you borrow a lot of money using compound interest. Okay, there are 2 types of interest, simple and compound. Okay, this is just a fact of life. And simple interest is, and by the way, I hope you have either printed this out or downloaded the set of notes so you can fill in these blanks as I explain these things. The simple interest is the interest where the same amount is added every period. Amount, okay? Here's a key word. That's a dollar amount, right? And so this is what we call a linear growth, and we'll be talking about linear and exponential growth later. On the other hand, the compound interest is it's an interest where the amount grows by not the same amount, but the same percentage. Okay, and there's a huge difference between the dollar figures, the same dollar figures, and the same percentage. But because the amount grows, okay, if a dollar grows to be $1.50 or something, then the 10% of $1 is different from the 10% of $1.50, as you learned in the previous lessons. All right, so the interest itself, the amount of interest itself grows more and more as time continues. And so it is called an exponential. It's a type of exponential growth. All right, we will be learning some formulas, and I am not really big on formulas, but certain formulas are going to be necessary in order to solve these problems in this chapter, okay, chapter 3 on money. So principal, this is the initial deposit. You also need to know these terms, financial terms, okay? And again, these are, not just used in the math classroom or in this class. These are the things that the words you'll be using as you deal with money for the rest of your life. So you might as well remember this. This word principal ends with an AL, not LE. That's a different word. And so this, the principal is the initial deposit. And since this letter, P is the first letter of the word principal, we use P to denote the initial deposit. This is how much money you are going to deposit into your bank account. We have this thing called APR, the annual percentage rate. And since this is the rate, we use R, but typically a lowercase. The time, this is, we can put T, but in this textbook, we use N. So we are going to use N for this. And then the future amount is going to be called P with a subscript N. And this is the amount of money you'll have after N years. Okay, sorry, I should be consistent in lower and capital letters. So capital N is the time in years. Okay, so let's find out what happens with a certain amount of money. Let's start with $100, okay? What happens to $100 with simple interest and with compound interest, both 5% annually, okay? And we'll be talking more about this in the second page. But right now, we assume that a 5% interest is added once a year. That's what annually means, okay? Once a year, and then see what happens with this amount. Now, year 0 is, of course, this is where you are going to deposit the money. So this is $100. Okay, we both start with $100. Suppose you have $100 in an account that gives you a simple interest of 5% annually, and another $100 in a different account with a compound interest of rate of 5% annually. All right. So now what's going to happen is that every year, this is going to be 5% of the initial value. Okay, so 5% of that is, i.e., $5. Okay, and this $5, remember, the simple interest is going to grow by the same amount. So it'll be $5 every year. Very simple, surprisingly. Okay, it's called simple interest. So after a year, it's going to be 105. After 2 years, it's going to be another $5 added to that. That's 110. And then the third year, it's going to add another $5, 115, 120. All right, you see what's happening here? So how did you find 105? Well, that's 100 plus 5, right? All right, well, let's not use the parentheses. And then how about the second one? Well, this time you added $5 again. So it'll be twice the $5 that you get every year. And then this one will be, of course, you do the multiplication first, right? In addition to the $100 in the principal, you have $5 3 times after the third year, and then 4 times after the fourth year. So you can get the formula. I hope you can get the formula. This is the power of mathematics. You generalize it so that you can find the formula for simple interest, the amount with a simple interest of 5% after n years. So how do you calculate this? P sub n, remember this is the amount after n years. P sub n is 100. Well, actually it's P. Well, maybe I should put 100. Either one is okay. Let's see. This is going to be P, right? 100 plus n times 5, right? So maybe I should, for this purpose here, I'm going to put 100 plus 5 times n. 5n means 5 times n, and this is how you calculate the amount after n years, right? With the compound interest, this is 5% added every year, okay? And there is a huge difference, and you may not see a huge difference after 5 years, but you will see a significant difference after many years. So let's see what happens after 1 year. 5% of $100 is added here. So the answer here is going to be $105, okay? Well, it's the same thing. Yes, it is. Compound interest is exactly the same as the simple interest for one compounding period. But then things change now, okay? This time we're going to add 5% of the new amount, $105. So the interest will compound depending on how much you end up with the previous year, okay? So how do you add 5%? Oh, by the way, maybe I should just go ahead and write this as well, okay? The reason I got this 105 is because I added 5% of 100, which you calculate, of course, as how? You calculate this as 100 times 0.05, right? Okay, and that's how you get the 5% of 100. So what we did is we added 5%, which is basically 105% of the initial value, okay? So that's how we calculated this. The next amount will be calculated this way. You take this previous amount, which was $105, and then you multiply that by 1.05 again, right? Now, why? Because you are going to get 105% of the previous amount. You see that? When you add 5% to some number, you are going to get 105% of that number, right? Remember the difference here? You can say 5% more of P, or you can say 105% of P, okay? So that's the difference, that more than versus of thing is coming up again here. All right, so this is actually the, you can rewrite this as 100 times 1.05 square, because you are multiplying this 100 by 1.05 and 1.05 again, all right? And so the amount here, as we will see, will be 110.25, okay? And then the next one, what's going to happen here? Well, this, I'm going to multiply this whole thing by 105 again, 1.05 again. So I'm going to now use the compact or the more concise notation, which is here, see, you have 1.05 one time, right? Here you have 1.05 twice. This time you'll have 1.05, 1.05, another 1.05. So it will be 3 of these. So then you multiply 100 by 1.05 raised to the third power. This is how you read this. It's 1.05 cubed or 1.05 to the third power, okay? And this turns out to be 115.76. Okay, and we'll do this calculation. Actually, let me just show you how you get these numbers before we go too much further, okay? All right, so if you have any kind of a PC or a Microsoft Surface or something, which carries which is operated by the Microsoft operating system, basically called Windows, you should click on the search, and then you should be able to find a calculator. Okay, every Windows system comes with a calculator, and then when you open the calculator, it looks sort of like this, a standard calculator, right? You can actually change this to a scientific calculator. Here's standard, scientific, programmable, and so on. Scientific calculator, okay? And you wouldn't see this. This is just what I was playing with before, but you should see all of these functions, trigonometric functions, different functions, square functions, the square roots, right? This is the one I was talking about, x to the y, the exponential, right? Not this exp, this means something else, okay? But this exponential function is what you will need. Now, what I was showing you is like 100, so it's 100, you see that, 100. And then you multiply that by times, okay, 1.05. 1.05, and you can see exactly what you're doing here, 100 times 1.05, and of course you get 105, right? But if you want to see this, like, let's say after 3 years, how do you get that? So what you need to do is, let's erase this, okay? If you want to find out 1.05 maybe I should do this, 100 times, okay? Now, listen carefully here, because I need to erase the whole thing. 100 times 1.05 to the third power. So it's 1.05. And what's this? Then you click on this and then 3. Okay, you notice here, I have 100 times 1.05 to the third power. Now, the scientific calculators are smart enough to know the order of operations. So it's going to do 1.05 to the third power first, and then multiply that by 100. When you press this equal sign or click on this, it'll give you the correct answer of 100 times, parentheses, 1.05 to the third power. Right, and that's this number here. Now it's $115.76.25. Of course, we truncate, anything below the cents. So the answer after 30 years will be 115.76. Okay. Now, if you are interested in after 4th year, here's what you do. Actually, I do the exponential part first. You don't have to do it this way, but 1.05 raised to the 4th power. You see that 1.05, this thing, and then 4th, and you can see exactly what you're doing here, and you can say equal to, and that's the parentheses part. 1.05 to the 4th power is this, and then you can multiply this by 100. And that's going to give you this amount, 121.55. Okay, so hopefully, you've seen how the scientific calculators work. And if you don't know how your scientific calculator works, you can contact me, or you can just find out, how these numbers work and how these systems work. Many times you have a caret for instance, Texas Instrument calculators have this caret key. It does the same thing as this. Okay. So what did I say? This was 100 times 1.05 to the 4th power. That's after 4 years. That's 121.55, right? That's the number I just showed you. And so let's do this in general. Okay, so what is the equation for the amount after the nth year? Well, you take 1.05 and raise it to the nth time, okay, nth power, okay? And then you multiply that by 100. And I just showed you how to enter this on your calculator. And that is how you find P sub n under the compound interest. Okay, so now the difference, after 1 year, there is absolutely no difference. After 4 years, there's a slight difference of like $1.55 out of $100. It's not a big deal, okay? But it turns out it does become a huge deal, all right? So let's not worry about this thing right now, okay? I'll come back to this. After 100 years, okay, let's try to find out what happens after 100 years. After 100 years, under the agreement of the simple interest, remember you're only getting $5 every year, right? So you get it's going to be 100. That's the original amount. Plus, remember you get $5 each of the 100 years. That's 500 years in total. I mean, $500 in total. In addition to the first $100, you will end up with $600. Well, somebody who is going to inherit your $600. Okay. Wow, that's great, right? Because your $100 is now multiplied to be 600, 6 times as much under the 5% simple interest. And that's great after 100 years. Well, it's not so good. After 100 years, if you had the compound interest, this amount will be 100. And then remember 1.05 to the 100th power. Okay, you do this part first. Your calculator will also know that to do this part first. And you take this amount, you multiply that by 100, and you will end up with a whopping 1,300, 150 and 13 cents. Okay, so you'll end up with not $100, not a $600, but you'll end up with $13,150.13. Okay, a huge difference between simple and compound interest. And that is the power of compound interest that would work for you if you save money, especially for a long period of time. And by the way, if you, like in old time, if you just put $100 under your mattress for 100 years, after 100 years, you will still get that exact amount of money, $100. So the simple deposit, simple interest is a good thing, but that's still no comparison between the simple and the compound interest after 100 years, or after even 50 years, or after even 20 years, okay? And that's why pretty much everybody uses compound interest, okay? And if you borrow money, because everybody uses the compound interest, this will work very much against you and for the person who is letting you borrow the money. All right, so we will stop at this point. In the next segment of this video, we'll be talking about compounding, but not annually, okay? Because many times these compoundings will happen every month, okay? Or every quarter, or every day, or continuously. So that's the second part of this lesson.